Good morning to one and all. My name is Ashok Nagalingam, working as Assistant Professor, Department of Mechanical Engineering, Student Institute of Technology. Now, discuss about the subject code ME3391 and subject name Engineering Thermodynamics. The subject handling for second year, third semester 2021 regulation. The course objective is to learn to teach fundamental concepts and law properties, entropy, apply them to analyze real world systems like engines, power plants and refrigeration, focusing on energy conversion, efficiency and problem solving using principles for open, closed systems, gases and pure substances. Knowledge on the basic and application of zeroth law and first law of thermodynamics. Second one, knowledge on the second law of thermodynamics in analyzing the performance of thermal devices. Number 3, knowledge on availability and application of second law of thermodynamics. Number 4, to teach the various properties of steam through steam tables and Molear chart. Number 5, knowledge on the microscopic properties of ideal and real gases. Ultimately, students learn to use thermodynamics for engineering design and analysis in other fields like heat transfer and fluid mechanics. This is the subject syllabus content. There are 5 units. The first unit is basic, zeroth and first law. Second unit, second law and entropy. Third unit, availability and application of second law. Fourth unit, properties of pure substances. Fifth unit, gas mixtures and thermodynamic relations. The overview of the content. This first unit, review of basis thermodynamic system, properties and process thermodynamic equilibrium, displacement work, P pressure volume diagram, thermal equilibrium, zeroth law, concept of temperature and temperature scales. First law, application to closed and open system and steady and unsteady flow process. What is engineering thermodynamics? Engineering thermodynamics is thermo means heat and dynamics means work. It deals with energy, heat, work and their transformation. It forms the foundation for mechanical systems like engines, refrigerator, power plant and heater, ventilation, air condition. This presentation will cover basic concepts, law of thermodynamics, properties of substances and applications. The second one is thermodynamic system and surroundings. To analyze energy interaction clearly, the entire universe is divided into two parts. First one is system and second one is surroundings. The thermodynamics system, specific quantity of matter or a region space selected for study. It is the main focus of thermodynamic analysis. For example, gas inside a cylinder, water in a boiler. Third one, steam in a turbine. Fourth one, air inside a compressor. For example, it is used in two system. The system surroundings. First one, surroundings means everything external to the system that can interact with it. This may include walls, atmosphere or adjacent devices. Boundary means is the real or imaginary surface that separates the system from its surrounding. Boundary may be fixed or movable, or real or imaginary. Next, types of thermodynamic system. These are two types. First one, control mass system. Second one, control volume system. There are control mass system. There are two types. First one, closed system. Second one, isolated system. Control volume system, one type, that is open system. What is closed system? Closed system, it's also called as control mass. No mass crosses the boundary, but energy in the form of heat or work may cross. Example, gas in a sealed piston cylinder. Second one, isolated system. Neither mass nor energy cross the boundary. Example, thermoflask, ideal case. Number 3, open system. It is called as control volume. Both mass and energy can cross the boundary. Example, turbine, compressor, pumps. Next one is property of a system. These are three categories. First one, extensive properties. Depends on the mass or size of the system. Additive nature. Example, mass, total volume, total energy, enthalpy, entropy. If an extensive property is divided by mass, it becomes intensive. For example, small v equal to capital V by m. Second one is intensive properties. Independent of mass of the system. Remain the same even if the system is divided. Example, temperature, pressure, density, specific volume, specific internal energy. These importance used to define the state of a system. Next one, specific property. Extensive properties per unit mass, always intensive. Examples, specific volume, specific internal energy, specific enthalpy, specific entropy. What is enthalpy? Enthalpy is thermodynamic property of a system defined as the sum of internal energy and the product of pressure and volume. H equal to U plus PV. H means enthalpy, U means internal energy, plus P means pressure, and V is volume. Entropy means is that measure the degree of disorder or randomness in a system. Next one is state, process, path and cycle. What is state? The explanation is when a system has fixed values of properties like pressure, volume, temperature, it is said to be in a particular state. If any one property changes, the state of the system changes. Example, a gas at 1 bar and 300 Kelvin is in a definite thermodynamic state. Process means a system initially at state 1 changes its properties. After undergoing a process, it reaches state 2. The path between state 1 and state 2 is called a process. Third point, path. Path means a system can move from state 1 to state 2 in many different ways. Each different way is a different path. Even if initially and final states are the same, heat and work depend on the path. Example, a gas can be compressed isothermally or adiabatically. Both reach the same final state but follow different path. Next one, cycle. The explanation is system starts at state 1, undergoes one or more process, finally comes back to state 1. Net changes in state properties equal to 0. Example, heat engines, Otto cycle, diesel cycle, Rankine cycle. Next one, thermodynamic equilibrium. These are the three categories. First one is mechanical equilibrium. There are no unbalanced forces with a system or between a system and its surroundings. For a system to be in this state, its pressure must be uniform throughout and must not change over time. Next one, thermal equilibrium, which two or more systems in thermal contact have the same temperature and no net flow of heat occur between them. Third one is chemical equilibrium, a reversible reaction where the forward and reverse reaction rates are equal, resulting in constant concentration for reactant and product over time. Next one is displacement work. The displacement work is the work done by a system due to the movement of its boundary during volume changes. This is a path function. Its value depends on the path followed during the process. This is important in analyzing engines, compressor, pumps and turbines, where expansion and compression process are involved. Next one is pure substances. Homogeneous substance with a fixed and uniform chemical composition throughout, even if it is exists in more than one phase. This application, steam power plants, refrigeration system, boiler and condenser. For example, water steam mixture, ice water mixture, pure gas such as oxygen and nitrogen and ideal gases. Next one is energy. Energy is the capacity to do work. These various form of energy. First one is kinetic energy, second one potential energy, third one internal energy, fourth one flow energy, fifth one heat and work. The energy is flow chart. Energies, there are two types. First one is macroscopic, second one is microscopic. What macroscopic is two category. One is kinetic and second one is potential. The kinetic formula is mv square by 2. The potential formula is mass, gravity, length. Next one is microscopic. Microscopic, there are four category. First one sensible, second one is latent, third one chemical, fourth one atomic. Sensible means some of the translational, vibrational, rotational, higher at higher temperatures. Latent means intermolecular phase changes. Chemical, atomic bonds. Atomic means bonds within nucleus of atoms. Next one is comparison between microscopic approach and macroscopic approach. What is microscopic approach? A certain quantity of matter is considered without taking into account the energy occurring at molecular level. This is known as classical thermodynamics. Microscopic approach, the level is taken into account for analysis. The value of these energies are constantly changing with time. This is known as statistical thermodynamics. Simple mathematical formula, this is statistical method. The values of the properties of system are their average values. Example, closed container, The pressure of the gas is the average value of pressure exerted by millions of individual molecules. Cannot be easily measured. This one is few variables. Microscopic approach, large number of variables. Next one is like heat and work. What is heat? Heat is energy transfer due to temperature difference. Heat energy means Q equal to M Cs and delta T. Q means heat, the unit is joule. M means mass, kilogram or gram. Cs means specific heat capacity. Temperature change degree Celsius. Work, energy transfer due to force acting through a distance. W equal to delta E, F into T. W into work done, del E energy transfer, F force, D equal to distance moved in the direction of the force. Heat and work are path function, not properties. Next one, zeroth law of thermodynamics. The states that if two bodies A and B are thermal equilibrium with the third system C, then the bodies A and B are thermal equilibrium with each other, A equal to B and B equal to C, and then A equal to C. Basic for temperature measurement. Next slide is first law of thermodynamics. This is energy conservation. Energy can neither be created nor destroyed, only transformed. A closed system formula Q minus W equal to delta U. Q means heat, W work done, del U change in internal energy. Any thermodynamic system and equilibrium state process a state variable called the internal energy between any two equilibrium states. The change in internal energy is equal to the difference of the heat transfer into the system and work done by the system. Common thermodynamic process. There are 5 categories. First one is isobaric, second one is isothermal, third one is adiabatic, fourth one is isochoric, fifth one is polytropic. A real world example, boiler water in an open pot or a kettle where the water turns to the steam at the constant atmospheric pressure. Polytropic, useful for modeling real world system like compressor. Equation PV N equal to C, where P means pressure, V means volume, N means polytropic index, C means constant. This is a standard international units system. Temperature Kelvin, pressure Pascal, energy joule, heat work joule or kilojoule. Concept of temperature. Temperature is fundamental thermodynamic property that indicates degree of hotness or coldness of a body. The direction of heat flow. Heat always flow from a body at higher temperature to one at lower temperature when they are brought into the thermal contact. Not a measure of heat content, but a measure of thermal state. It is related to the average kinetic energy of molecules in a substance. Two bodies are said to be in thermal equilibrium if they have the same temperature, zeroth law of thermodynamics. Next one is temperature scales. The temperature scale is 4 types. First one Celsius scale, second one Fahrenheit scale, third one Kelvin scale, fourth one Rankine scale. Celsius scale, freeze point of water 0 degree Celsius, boiling point of water 100 degree Celsius, widely used in daily life and engineering applications. Fahrenheit, freeze point of water 32 degree Fahrenheit, boiling point of water 212 degree Fahrenheit, mainly used in the USA. Kelvin scale, absolute temperature scale used in thermodynamics. 0 point, absolute zero, where molecules motion theoretically cases. Freeze point of water 273.15 Kelvin, boiling point of water 373.15 Kelvin. No degree symbol is used. Ranking cycle, absolute scale based on Fahrenheit, 0 point at absolute zero, used mainly in some engineering fields. Application of thermodynamics, power plants, refrigeration and air condition, internal combustion engines, compressor and turbines, heat exchangers. Thank you.